So as we continue to learn and understand how the routes get into the routing table, and then once they're there, which route is going to be used by the router, let's take a few moments and do a few review questions to confirm our understanding. So let's start with question number 1. Which of the following static routes would show up in the routing table? So the scenario is this. We've been asked to input all of these static routes into the Cisco router, and once we do so and do a show IP route, which of these routes would show up in the routing table? So as we look at this together, one approach would be, let's take a look at what's being added. So here we have the 55.1.2 network with a 24-bit mask. This is the 51.1.2.0 network with a 25-bit mask. And then we have this one, 55.1.2.0 with a 24-bit mask. So if we look at these, this network right here, I'll use a different color. So this network right here, this route, and this route are for the same network. They're both 24 bits. Each of them use a different next hop. So this top one uses the next hop of .11. The bottom one here uses the next hop of .12. But check it out. Here, there's an administrative distance that's been added. Up here, the default administrative distance for a static route would be a AD of 1. Answer D, that one would be a floating static route because the other one has a better administrative distance. So D would not show up in the routing table as a result. So that's out. And as far as the other three, these are 3 separate networks. We have a 24-bit network, a 16-bit network, and a 25-bit network. And as a result, A, B, and C, those 3 routes would show up in the routing table, presuming that they have a valid next hop that can be reached by this router. Question number 2. Which route, based on this routing table, will be used to forward a packet to the destination IP address of 10.16.8.111? And so as we look at this question, I'm looking at the title of the reference video, using the longest match in the routing table. This is probably going to be a situation where we have more than one route that would work, but we're going to look for the longest match, which is the first rule of the road when making routing decisions. Look for the longest match in the routing table. So if the router is forwarding a packet or trying to forward a packet to 10.16.8.111, and we look at the routing table, these 2 routes, they both start with 10.16.8. So that would definitely cover the first 3 octets. And regarding the 111, that .111 would fit into this route, and it would also fit into this route. So they're both possibilities as far as like the range of addresses that they fit into. But if we're looking for the longest match, which is what the Cisco router would do, it would choose the 24-bit route over the 21-bit route every day of the week. So the answer is the OSPF learned route of 10.16.8.0 at the 24-bit mask, which has an administrative distance of 110, a cost of 2 with the next hop of 10.16.7.6, and the outbound interface is going to be gig 2/0. This router is ready to rock. If it gets a packet for this IP address, that is the route it's going to use to forward that packet on its way. And question number 3, what ranges of IP addresses would be included in the route 55.1.2.0 with a 29-bit mask? So the logic we could use to identify that range would be the same logic we'd use to identify the range of a subnet. And that would be, it's a 29-bit mask, so the first 24 bits at least are all in stone. So the range would be 55.1.2. something. And then to break out that last octet, we'd go ahead and put it into binary, 128, 64, 32, 16, 8, 4, 2, and 1. And if you're saying, Keith, you're a double CCIE and you're still writing these out, the answer is, yeah, I love to teach. And I also like to make sure that I'm sharing this information and a way to accomplish the goal or figure it out for anybody, including you and I, who wants to learn it. So this is our 24-bit boundary. And so if we're going on to 29-bit mask, so if we put the mask out in 29 bits, starting here would be 25, 26, 27, 28, 29. There's the dividing line, network on this side, host bits on this side, and these would be zeros. So if this is the network 55.1.2.0, which it is with a 29-bit mask, the block size is 8, which means the next subnet is going to be 8 more. So the next subnet, I'll put N here for next, would be 55.1.2. And in the third octet, we'd add 8 more. It'd be 8. And then the next subnet after that would be 16. And the next one would be 24. We just keep adding 8. Now the reason that helps us is because we can figure out the range for this subnet right here, the one in question. So the first address would be .1, and the last one would be the next subnet -2. So the range would be .1 through .6 with a broadcast address of .7. So in answer to the range of addresses that would be included in this route, it would be 55.1.2.1 through .7 if we were going to include the broadcast address from that range of addresses. So thank you for joining me both in these videos and also for this review regarding predicting an IP router's forwarding decisions in an IPv4 network. I hope this has been informative for you, and I'd like to thank you for viewing.